know that the Bohr models of the hydrogen atoms, it is an improvement of the Rutherford's nuclear models of atoms, because these Bohr models accounts or described the stability and the line spectrum of the hydrogen atoms and hydrogen-like ions. As for example, the He plus helium, the singly positive charged, lithium doubly positive charged, and beryllium in the triply positive charge, and so on. That means whoever ions has one single electron, this type of atomic models is nicely described by the Bohr's atomic model. But Bohr models were unable to describe the finer structures of the hydrogen atom spectrum. These finer structures were observed by using the very sophisticated spectroscopic techniques. And these finer structures of hydrogen atom spectrum, that time the Bohr's model cannot be explained. You see that this is the major spectrum line, and these all are fine spectra. So this fine spectrum, this fine structure could not be explained by the Bohr models. So this is the number one limitations. Second limitation is that the model is also unable to explain the spectrum of atoms other than hydrogen. For example, helium atoms. When it in the neutral helium atoms, it is actually a noble gas. It has the 2 electrons. So this type of atoms, it cannot be explained by the Bohr's model. So this is the second limitation of the Bohr's atomic model. Third limitations, that we know that with the improvement of the science, we see that there is the Zeeman effects and Stark effects. What is the Zeeman effects? Because the spectral line will be split in the presence of the magnetic field. You can see here in this left side, if there is no magnetic field, then only from ground state to excited state, one state will come. But in presence of magnetic field, from the ground state, 3 excited states will be observed. And from this, the 3 line will come, because if you see that, if you put the arrow, then you see that it is excited in the 3 different states. So 3 different line will come in presence of magnetic field. But if magnetic field is not there, then from the ground state, only one excited state you will find. And this is called the Zeeman effect. So Zeeman effect is the splitting of the spectral lines in presence of the magnetic field. And these Zeeman effects cannot be explained by the Bohr's atomic model. Another effect is the Stark effect. Stark effect happens in presence of the electric field. You can see here that from this state, which is coming to the ground state, then only one line you can see here. But in presence of the weak electric field, because in the left side is the no field, so this case only this type of line you can observe in the spectrum. 1, 2, 3, 4. But when the weak electric field is there, then you can see the different excited state is there. Whether it is the 1, in this case top, this is 1, but in the second down, this is the excited state, this split with the 1, 2, 3, 4. And in that way, from the top, you could go below the third excited state, then also you will find the 2 excited state in presence of the weak field. So in this way, if you come to bottom, then you can see that when it is no electric field is there, then only 1, 2, 3, 4, 5. This 5 line will be observed in the spectrum, atomic spectrum. But in presence of the weak electric field, then you will see the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 line will be observed. And this is called the Stark effect. This Stark effect cannot be explained by the Bohr's atomic model. And this is also one limitation for the Bohr's atomic model to describe the spectrum. And the fourth limitation is the Bohr's theory was unable to explain the ability of atoms to form the molecules by chemical bonds. Because now we know that during the formation of the chemical bonds, and we'll find later also, because this chapter will come later. So it is the either exchange of the electron or the sharing of the electrons. So this type of concept was missing in the Bohr's atomic theory. So whatever we understood from the limitations of Bohr model, that these limitations, to overcome these limitations of the Bohr's atomic models, we need a better theory which can explain these fine structures of the spectrum and the chemical bond formation. That means the structure of the complex atoms.